car starts from rest at A and accelerates uniformly at 1 meter per second squared along a straight level road towards B, where the distance between A and B is 1914 meters. When the car reaches its maximum speed of 32 meters per second, it continues at this speed for the rest of the journey. So we will say that at t equals 0, a car leaves point A. Its initial speed or velocity is 0. It accelerates to the right with a magnitude of 1 meter per second squared. When it reaches a speed of 32 meters per second, it continues with this speed for the rest of the journey. So the acceleration drops to 0 when it reaches this speed. At the same time as the car starts from A, a bus passes B, travelling towards A with a constant speed of 36 meters per second. 12 seconds later, the bus starts to decelerate uniformly at 0.75 meters per second squared. So the bus leaves or passes this point B at the same time that A starts out from this point. So if A starts at t equals 0, then B has to start at t equals 0. The bus is travelling with uniform speed 36 meters per second. That means its acceleration is 0. So I'm doing acceleration in blue and velocities in red. So 12 seconds later, the bus is somewhere here. And we are told that it starts to decelerate at t equals 12. So it's been traveling with constant velocity all along. If it decelerates, it means that its acceleration vector is in a direction opposite to its velocity vector. So its acceleration vector is pointing in this direction because the bus is moving to the left. And the magnitude of this acceleration vector is 0.75 meters per second squared. At this instant, the velocity of the bus is 36 meters per second to the left. But of course, after t equals 12, this velocity vector will decrease in magnitude by 0.75 meters per second each second. The car and the bus meet after t seconds. Find the value of t. What I will do is find the time it takes for the car to do 32 meters per second. If we take directions to the right as being positive for car, then we have the initial velocity is 0. This acceleration vector will be positive, it will be plus 1. The final velocity of the car will be positive as well, so we're taking directions to the right as positive. From v equals u plus at, we can calculate the time. The time comes to be 32 seconds. We can also get the distance travelled by the car when it reaches this point here. We can use the formula v squared equals u squared plus 2as. So the v is 32, u is 0, a is 1. Rearranging this formula and plugging in, we get s equals 512 meters. That's the distance travelled by the car when it gets to here. Now let's see how far the bus has travelled when it has been travelling for 12 seconds. So t is 12, the initial velocity or speed is 36 meters per second, the acceleration is 0. I'm taking directions to the left as positive for the bus. Since a is 0, we won't be using this part of the formula. Our formula is just a case of distance equals speed multiplied by time. This is the case when we're dealing with constant speed. Our speed equals distance divided by time. So we get 432 meters. Now we know where the car is at t equals 32 seconds. We know it's 512 meters from A. We're going to be interested in where the bus is at t equals 32 seconds. We know where it is at t equals 12 seconds. It's 432 meters from B. So we want to get to see where both car and bus are at the same time, namely at t equals 32 seconds. So you can imagine setting the timer to 0 when the bus is here. So we can imagine now that t is 0 at this instant for the bus. And we need to see for how many seconds the bus will be travelling to reach a time of 32. Well, that's 32 minus 12, which is 20. So we have to use t equals 20 in our formula. So the acceleration is negative here because we're talking about a deceleration. Directions to the right are positive, so this acceleration vector, which is magnitude 0.75 meters per second squared, is a negative acceleration vector. We plug everything in here and we find that the distance that the bus travels from t equals 12 to t equals 32 is 570 meters. So now here is the bus at t equals 32 seconds. So it took 20 seconds for it to go from here to here. And the distance it covered is 570 meters. We can now get the distance between the vehicles at t equals 32. That's this distance in here. The total distance between A and B is 1914, so we just subtract off these three distances and we get 400 meters. So this distance here is 400 meters. So now we need to analyze the motion of the two vehicles as they travel over this distance of 400 meters. The motion of the car is fully specified. We have its velocity, 32 meters per second, and its acceleration is 0, so the car is traveling with uniform velocity. We know that the bus is uniformly decelerating by 0.75 meters per second squared. However, we need the velocity of the bus at this instant. We have its velocity at t equals 12, so 20 seconds later we need to get its velocity, that is at t equals 32. So we have u for the bus. The acceleration is negative because we're taking directions here to the left as being positive for the bus. So a is minus 0.75, the bus is slowing down, and t is 20. It takes 20 seconds for the bus to go from here to here. That's 32 minus 12. Plug everything in, we get 21 meters per second. So now we have the velocity of the bus at t equals 32. So this is the magnitude of the bus's velocity. So these numbers that I'm writing are magnitudes. At t seconds, both vehicles will meet each other. So now we assume that at t equals 0, the car is here. I'm just copying this diagram down. Well, actually at t equals 32 the car is here, but we're setting the timer now to t equals 0. So t equals 0, c is the position of the car. And for particle B, at t equals 0, it's here. So this point and this point correspond to this point and this point. This is the car, this is the bus. And I've written in the magnitudes of the velocity vectors in red, and the bus has an acceleration 0.75. The car has no acceleration. And the distance between them is 400 meters. So we're interested in the position of the car after t seconds. So the initial speed of the car is 32. So for the car I'm taking directions to the right as being positive. A is 0 for the car. So we just have distance equals speed times time. So t is the time taken for the vehicles to meet. Now for the bus, I will take directions to the left as being positive. So the initial velocity of the bus will be plus 21. What about the acceleration? Well, the acceleration is going to be negative. It's acting to slow down the bus. It's opposing the velocity of the bus. So we plus a half times minus 0.75. So now we have the distances travelled by both car and bus when they meet. So we're assuming that t is the time at which they meet. But what's so special about these two distances? Well, the sum of them must be equal to 400. Both these distances will come out to be positive because I followed the correct convention. Distances to the right are positive for the car, distances to the left are positive for the bus. And the total distance travelled by both bus and car when they meet will be 400 meters. So, adding these two together, setting them equal to 400, leads us to this quadratic equation. If we solve this quadratic equation, we get two values for the time for the vehicles to meet. One answer is 8 seconds, the other answer is 133 and a third seconds. Now, the smaller time is the answer to this question. After 8 seconds, the two vehicles will meet at some point, and this distance plus this distance will equal 400 meters. This larger value is the sum of these two distances, is the time taken for the sum of to be 400 meters. Now let's see how far the car is after travelling after 8 seconds. So t equals 8, the vehicles collide somewhere along here. So the car's speed is constant. So from s equals ut plus a half at squared, we get 32 times 8. The acceleration is 0. So we're just talking about speed times time. By the way, the answer to part 1 of the question is got by adding 8 seconds onto the time taken for the car to get to here. Its t equals 0 here in this, for this leg of the journey, but this time corresponded to t equals 32. So we have to add 32 onto 8. The question is, what's the relevance of this value here? It's not the answer to the question, of course. It's far too big. Remember, the bus had a deceleration of 0.75. The bus is moving to the right, so directions to the right are positive. But what will happen is, if the deceleration continued to be 0.75, the bus will come to a stop. Imagine that it doesn't collide with the car. Imagine it passes through the car. Its acceleration is 0.75. Now, if you can just pretend that its acceleration is always 0.75 to the right, then the bus will actually move backwards. It will come to a stop and move backwards. It doesn't happen, of course, in reality, but the formulas assume that the acceleration is constant, never changes. It's always 0.75. So the bus will slow down, stop, and reverse direction. Actually, this time t equals 133 1/3 corresponds to the bus being somewhere to the right of this point, which means that the distance, or the displacement vector SB, will be negative, because remember, we took displacements of the bus, that is vectors pointing to the left, as being positive. So SB is this vector here, the position of the bus at t equals 8, which is positive. But if the bus was able to slow down, stop, and reverse direction, so the collision didn't happen, so the bus passed through the car, if you like, or passed beside the car, then it would accelerate back through its original position with acceleration 0.75 to the right, and at this time it would end up somewhere here, and SB would be negative. However, SA, the position of the car, so the bus and car collides again, or pass through each other at this point here, SC, the position of the car, will be greater than 400. So when we take SC and add it onto SB, so we have a number greater than 400, we have a negative number, we will get 400. Of course, this situation is physically impossible, but that's what the equations tell us. The equations don't assume that the bus decelerates to a stop. They assume that we're talking about a particle with deceleration 0.75. Particle will come to a stop and accelerate to the right with acceleration 0.75. In the next question, we want to find the distance between the car and the bus after 48 seconds. Well, we know that after 40 seconds, car and bus collide. So that's what we got from part 1. So after 48 seconds, we're talking about a further 8 seconds. So we can set the timer to 0 here when the particles collide. So this is the situation at t equals 0. So for 48 seconds, we need to consider the distance between the vehicles at 8 seconds. That's 48 minus 40. Here I have the magnitudes of the velocities and accelerations of both vehicles. UC and AC are the velocity and acceleration of the car. This is the car. And AB and UB are the magnitudes of the acceleration and velocities of the bus. So we'll take the origin of coordinates as here, and we're going to find out how far away both vehicles are from this point at t equals 8 seconds. So both particles are together at t equals 0. What's missing here is the speed of the bus. We can get that from the first part. It took 8 seconds for the bus to go from here to the point where it collides with the car. And we have the initial speed and acceleration when the bus was travelling from here to here. So u is 21, directions to the left are positive, a is minus 0.75 because a is pointing to the right, the negative direction, and t is 8. So the bus is slowing down as it goes from here to here. So that's why a is negative. From v equals u plus at, we find the speed of the bus when it collides with the car is 15 meters per second. So we can write that in. So let's get the distance travelled by the bus. The bus is travelling to the left but slowing down, so the acceleration is negative. So for the bus, taking directions to the right is positive. As for the car, it is moving to the right, so for the car we're taking directions to the right is positive. It has no acceleration, so its distance is just its speed times the time of travel, which is 8. So the bus is 96 meters away from the point where the vehicles met, and the car is 256 meters away from the point where they met, both vehicles met. So the distance between the 2 points is 256 plus 96, which is 352 meters.